This video will cover the quantitative relationships between various soil constituents, including particle density, bulk density, total porosity, void ratio, air-filled porosity, mass wetness, and volume wetness. Soil is composed of pore space, which includes air and water, and solid space, consisting of organic and mineral matter. A typical mineral soil has approximately 45% mineral, 5% organic matter, 25% air, and 25% water. Particle density, also known as mean particle density or true density, is the mass of oven-dried soil divided by the unit volume of soil solids, excluding pore space. It depends on the chemical and mineralogical composition of the soil and is typically 2.65 grams per cc for mineral soil. Bulk density, or apparent specific gravity, is the mass of oven-dried soil divided by the unit volume of soil, which includes pore space. Higher bulk density indicates greater compactness. Bulk density generally increases with depth of soil. Bulk density increases with greater compactness, peaty structure, and depth. It decreases as the amount of pore space, fineness, organic matter, and moisture content in swelling soil increases. Crumb structure in clay soil leads to low bulk density. Peaty structure, sandy soil, and waterlogged soil result in high bulk density. Particle density is always greater than bulk density. If pores occupy half the volume of the soil, the bulk density is half of the particle density. Specific volume is the reciprocal of bulk density. It is an index of the degree of compaction or looseness of the soil. A high value indicates a low level of compaction. Total porosity is the volume occupied by pores per unit volume of soil, expressed as a percentage, typically ranging from 30 to 60%. Pore space directly controls the amount of water and air in the soil and indirectly influences plant growth. For soils with the same particle density, the lower the bulk density, the higher the total porosity. This is often the case for uncompacted, well-granulated soil and undisturbed natural vegetation. Macropores are water-conducting pores larger than 0.06 millimeters, allowing easy movement of water and air. Micropores, or capillary pores, are smaller, restricting water and air movements. An equal proportion of both is ideal for optimum plant growth. The porosity of soil can easily be altered. Factors affecting porosity include soil structure, texture, organic matter, depth of soil, cropping, and puddling. Granular and crumbly soil is generally more porous than prismatic and platy soil. This slide visually demonstrates different soil structures that influence porosity. Void ratio is the volume occupied by pores divided by the unit volume of soil solid. It is an index of the relative volume of pores and is greater than porosity. Porosity is used in agriculture, while void ratio is primarily used in engineering. Porosity ranges from 0.3 to 0.6 as a fraction, and void ratio ranges from 0.3 to 2. Mass wetness, or gravimetric water content, is the mass of water per unit mass of oven-dried soil. For mineral soils, this typically ranges from 25% to 60%, depending on bulk density. Volume wetness, or volumetric water content, is the volume of water occupied in pore space per total volume of soil. At saturation, volumetric water content equals porosity. Degree of saturation is the pore volume occupied by water per total volume of pores, expressed as a percentage between 0% and 100%. Complete saturation is rarely attained in the field because some air is always trapped. Air-filled porosity is a key characteristic in soil science. Air-filled porosity is the volume of air in the soil. The depth of water in a soil layer can be calculated using volumetric water content and the depth of the soil layer. The weight of a furrow slice refers to the oven-dried weight of soil for 1 hectare area to a depth of 15 centimeters. This weight is used for calculating the amount of fertilizer and amendments needed. We will now review some numerical problems related to these quantitative soil relationships. This slide is for a numerical problem. 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 Viscosity is the resistance to flow caused by internal friction between layers in a liquid as they move at different velocities. The unit of viscosity is dyne second per centimeter squared, also known as poise. Water at 20 degrees Celsius has a viscosity of 1 centipoise. Factors affecting the viscosity of clay suspension include temperature and electrolyte concentration, both of which are inversely proportional to viscosity. The type of clay mineral affects viscosity, with montmorillonite having higher viscosity than kaolinite. Exchangeable cations also influence viscosity, an effect known as the lyotropic effect. If a highly hydrated ion is adsorbed on the surface of a particle in a dispersed aggregate condition, the volume of the particle and the viscosity will both increase.